Unit 8, Day 4, Interpreting Square and Cube Root Functions. This is Mr. McGough in R12, and I'm going to go over our Day 4 lesson. So let's start off with a bit of review. The question asks us, if we let f of x equal the cube root of x, and we let g of x be a translation of f of x, expressed as g of x equals f of x minus 27, it asks what are the coordinates of the x-intercept of g of x. Well, first off, let's see what this really means. It means that for g of x, we've replaced x with x minus 27. So we would rewrite this g of x as the cube root of x minus 27. So we're going to evaluate the cube root of x minus 27 for the x-intercept. Well, the x-intercept is where our graph crosses the x-axis, which is the place where g of x equals 0. So we're going to take this and we're going to find at what point the cube root of x minus 27 is equal to 0. So we're going to use algebra, obviously. So we take the cube root of x minus 27, and we set it equal to 0. And then we need to do the same thing to both sides. What's that thing going to be? We're going to cube both sides. So the cube root of x minus 27 cubed becomes x minus 27. And we set that equal to 0 cubed, which is 0. So we're going to add 27 to each side. And x equals 27. And y equals, well, it's the x-intercept, y equals 0. So that's letter C. Now we're going to move on to today's lesson. We're going to state the domain, range, and behavior and transformation of the following radical equations without graphing them. So if the parent function is g of x, then we're going to rewrite the given function in terms of g of x. And we're going to think about it this way, with the parent function. What that really means is g of x, it's the square root, it means g of x would be the square root of x. And we're going to rewrite it in that terms. If it's a cube root, then g of x, the parent function, would be the cube root of x. So those are the parent functions. So first off, domain. We know that for a square root, we cannot have a negative number inside the square root, or it will be an imaginary result. So to get a real number out, my domain has to be at least starting at x equals 4. 4 is fine, square root of 0 is 0, and I would get 5 out. If I had 5 in there, 5 minus 4 is 1, square root of 1 is 1, 1 plus 5 is 6. So my domain is all real numbers as long as x is greater than or equal to 4. For my range, well, like I said, if I put in 4 minus 4 is 0, square root of 0 is 0, plus 5 is 5. So my range is going to start at y equals 5, and then it can keep going up. My end behavior, I know that as x approaches positive infinity, the number inside of my square root approaches a very large number, infinity, and then I add 5. So as x approaches infinity, f of x approaches infinity. And what is my transformation? Well, there's h, and there's k. And as a reminder, it's x minus h. So my transformation is right 4, k is positive, up 5. And what is f of x in terms of g of x? F of x is a square root. So g of x was that square root of x. So what is f of x? It's g of x minus 4 plus 5. Problem number 2. Cube root. I can have positive or negative numbers inside of a cube root. So x is unrestricted. My domain, my x values, I can get my pen to work, could be any real number, all real numbers. My range, again, unrestricted. If x is a large negative number, my cube root is a large negative number. I subtract 3, it's still a large negative number. If x is a positive number, cube root of a positive number is positive. If it gets really big, minus 3 means nothing. So this is one of those graphs. It says not to graph it, but it's going to look like that. So I know my end behavior. As x approaches positive infinity, f of x will approach positive infinity. As x approaches negative infinity, f of x will approach negative infinity. My transformation, my h value. Let me do the red pen again. My h value is negative 7 because it's x minus h. My k value is negative 3 because it's plus k. So x minus negative 7 plus negative 3. So my transformation is left 7 and down 3. Again, f of x, when I try to compare that to the parent function, the cube root of x, f of x is going to equal g of x plus 7 minus 3. Number 3. My blue pen back. Without graphing. First off, raising to a 1/2 power means I can really rewrite this as negative 1/2 times the square root of x plus 8, and all of that minus 1. So again, I know that inside my square root, I cannot have a negative number. So when would that be equal to 0? That would be when x equals negative 8. Then x could equal any number bigger than that. So my domain is all real numbers such that x is greater than or equal to negative 8. If x was negative 8, negative 8 plus 8 is 0, times negative 1/2 is still 0, minus 1 is negative 1. What if x was minus 4? Minus 4 plus 8 is positive 4, times negative 1/2 would be negative 2. Minus 1 is negative 3. So that's smaller. So my range would be all real numbers such that f of x is less than negative 1. Well, it says you don't have to graph it, or not to graph it. You could still do a t-table. X and f of x. Again, if x is negative 8, f of x is negative 1. If x is negative 4, the square root of 4 is 2, times negative 1/2 is negative 2. It becomes negative 3. If x was negative, let's see, I want 9 as my next one, so x would have to be 1. 1 plus 8 is 9. Square root of 9 is 3, times negative 1/2 is negative 3/2. I just made an error. This should be negative 2. Negative 3/2 minus 1 is negative 5/2. So negative 2.5. So my end state behavior, what's happening here? Well, as x approaches positive infinity, f of x will approach negative infinity. What is my transformation? Well, h is negative 8, k is negative 1, and I have a compression and a reflection. Compression because my a value, the absolute value of a, is less than 1, and a reflection because it's a negative coefficient. So my transformation is left 8, down 1 compressed times 1/2 and reflected, or flipped. F of x, well, when I look back at my parent function is again the square root of x, or x to the 1/2, whichever way you prefer to call it. So f of x would be g, oh, wait a minute, I have a multiplier. It's going to be negative 1/2 g of x plus 8 minus 1. Number 4. X to the 1/3 is really the cube root of x, so I can rewrite this, negative 25 over 72 times the cube root of x minus 121. So my domain, well, I can have positive x or negative x, no restrictions there. The range, well, if x is negative, my answer is negative. If my x is a large positive number, we're negative 25 times, actually, the other way. If x was a large negative number, I'd multiply that by another negative. That would become positive. And then if I subtract 121, if x is a big enough negative number, it blows away 121. So my range is also unrestricted. End behavior. I have to look at the fact that this is being flipped. So as x approaches positive infinity, it becomes very large. If my cube root of a very large number is positive, and then it gets multiplied by a negative, that's a large negative number. And then I subtract even more from it. So f of x would approach negative infinity. Similarly, as x approaches negative infinity, I have a very large negative number inside my cube root. I take the cube root of that, it's a large negative number. I multiply it by a negative, that becomes a large positive number. And then I subtract 121, so f of x approaches positive infinity. My transformation, I have no h, so it's not being shifted left or right. I do have a k, it's being shifted down 121 units. And I have this multiplier. Multiplier, the absolute value of that is less than 1, so it's being compressed. Compressed by a factor of 25 over 72, and it is being reflected. For f of x, again, my parent function is a cube root function, so really, f of x and g of x, f of x is the transformation, negative 25 over 72 times g of x minus 121. And that's the end of day 4.